The Troxler effect, also known as Troxler's fading, is a fascinating perceptual phenomenon. It describes how a stationary image in your peripheral vision will gradually fade away if you fix your gaze on a central point. This occurs because your brain prioritizes changes and movement in your visual field, essentially tuning out constant, unchanging stimuli. This fading effect is caused by neural adaptation. When neurons in your visual cortex are constantly stimulated by the same unchanging image, they become less responsive over time. This reduced neural activity leads to the image appearing to disappear. Lateral inhibition and synaptic fatigue in your retinal ganglion cells also contribute to this process. It's your brain's way of conserving energy and focusing on new information. You can easily experience the Troxler effect yourself. Find a stable image with a uniform background, such as a ring, a colored shape, or even a simple pattern. Focus your eyes on a specific point within the image. After about 10 to 30 seconds of steady fixation, you should notice the surrounding image beginning to fade or disappear altogether. Blinking or moving your eyes will reset the effect. For best results, ensure the image has a uniform background and maintain steady eye fixation without movement. The Troxler effect shares similarities with other fascinating visual illusions that reveal the brain's role in perception. One related phenomenon is the Ganzfeld effect, which occurs through sensory deprivation. When visual input is uniform and unchanging, the brain can generate hallucinations as it fills in the missing sensory information. Another related illusion is inattentional blindness, where people fail to notice an obvious object or event because their attention is directed elsewhere. This demonstrates how selective focus can filter out important information from our awareness. Together, these illusions, including the Troxler effect, highlight that perception is not a passive recording of the world, but an active construction by the brain, heavily shaped by attention, context, and expectations. The Troxler effect has practical applications, especially in virtual and augmented reality. VR headset developers are using Troxler-inspired mechanisms to reduce motion sickness by simulating peripheral fading during prolonged use. Adaptive fading in AR displays can also extend user immersion without causing eye fatigue. By understanding and leveraging this effect, developers can create more comfortable and engaging immersive experiences. Researchers model the Troxler effect in artificial neural networks to improve computer vision algorithms. This creates AI systems that mimic human attentional fading, enhancing efficiency in tasks like object detection in static environments such as surveillance or autonomous vehicles. By ignoring redundant or unchanging information, these AI systems become more efficient and accurate. Interestingly, research suggests that individuals with attention deficit hyperactivity disorder, or ADHD, and autism spectrum disorder, or ASD, may experience altered Troxler fading compared to typically developing individuals. This could be due to differences in dopamine pathways, which play a key role in attention and perception. Dopamine is a neurotransmitter involved in motivation, reward, and cognitive processes. Brain imaging studies show differences in functional connectivity in individuals with autism spectrum disorder compared to typically developing controls. These differences may contribute to altered perceptual experiences like Troxler fading. These findings are spurring biomarker research for diagnostic purposes, potentially leading to new tools for understanding and addressing these conditions. In clinical contexts, 40% of ADHD-diagnosed individuals report minimal fading, with research showing correlations to dopamine levels. The study of the Troxler effect is continuously evolving. Future research will likely focus on personalized applications, such as neurofeedback devices that train users to overcome fading for improved focus. Ethical considerations, such as privacy in AI systems that track eye fixation patterns, will also need to be addressed. As our understanding of the Troxler effect deepens, it holds immense potential for enhancing technology, improving mental health treatments, and revealing more about the inner workings of the human brain.